What's that number 12?
Yeah, 2007.
Fall 2007, number 12?
Wait. Just hold that thought. Final. So I already did the first draft of the final. If memory serves, the sort of things I asked you were lines and planes. Right? In particular for planes, I'm sure I asked two kinds of questions. One, find general plane given some info and find tangent. Alright, so I asked a couple questions on planes, so really know about planes. I asked you both to find the tangent plane to some surface, so you should know how to do that, and find some general tangent plane if I give you some information. So if I ask you, find the plane that contains a line and a point, or the plane that contains 3 points, or questions like that. I would ask something like that. Surface area, definitely coming on. Volume is definitely coming on. Right, I asked a similar problem on the I think test 3, where I asked you to set up 2 triple integrals and only evaluate 1. I'm going to ask a similar problem to that, so know how to set up integrals very well. Of course, there's directional derivatives. Using the chain rule, that short formula, so it's something like dz dx is just, minus fx over fz, using that formula and things like that. What else did I ask? Mass. On the test, I just asked you to write down the formulas, but I'll actually ask you to do a problem. I'll actually ask you to go through and do the integral, set it up, and do it actually. It's a full problem. And directional derivative, of course, things like including max rate of change, etc. And direction of maximum rate of change. In the it's 2 parts. At the moment, it's still just a draft, but at the moment I have 11 problems on it. I don't think I'll change that. Currently there are 11 problems. 7 in part 1. 4 in part 2. And you're going to be required to do all in part 1. And choose 3 from part 2. So part 1 is the mandatory section, and this guy includes 2 series problems.
You're not joking, right?
You mean like 8.5 to
So
8.7?
there's one that covers 8.1 to 8.4. So just like in the test, tell me if it converges absolutely, conditionally, or diverges. I think I asked 3 series, maybe 4. 3 series, probably. And there's a radius of convergence. Radius of convergence, interval of convergence. But remember, that's just applying the ratio test. You always do the ratio test. Let's see, what else? In part 2, there is one series problem. Some of you may want to skip. Okay, what did I ask? Oh, it's approximating an interval. Using power series and judge how good the approximation is. And of course that just means the alternating series approximation theorem, usually. That's the only one we sort of know. Series approximation theorem. Okay, so surface area I asked, volume I asked about, setting up integrals I asked about.
Could we try all 4 and take the best 3?
Sure, I would do that, yeah.
How much time would we have same amount as last
The exam is 2 hours and 15 minutes long. I mean, class time is 2 hours 20 minutes. I mean, I'll give you 2 hours 20 minutes. Anything else that jumps out? I don't think so. Yes, definitely, yes, linear approximation.
Not the time.
That's an important one. So I'm going to give you a function and say approximate its value at this point.
Would we get a
That's
I believe this is in part 2.
would we get a problem about like finding the error in measurements? Like if you made an error in
No.
length with okay. Good.
I didn't put one on that. But there's a linear approximation, which is, it's sort of, it's almost the same.
What about like maximum stuff?
Yeah, the stuff finding and classifying critical points, yes. I think that's in part 1.
Also, it's meant
Like the tangent line, a vector.
Did I ask about a tangent line? I don't recall. I don't think so.
Of the x, y, and z.
I don't think I asked a problem like that.
So it's roughly going to be 10 points a problem.
Yeah. 10 problems, 10 points.
And these are all just regular problems, or like part A and B?
Well, in part 2, they usually have like A and B, maybe A, B, C.
Okay.
In part 1, a few has parts, but it's usually just one thing.
Limits?
There's a limits, which is in parts. I probably attached it to the surface area, but I don't remember. But yeah, I'm going to ask you about 2 limits.
that would be one question.
And that would be like part B of a question. I forgot what part A was. And I also think that's in part 2. They're very similar to the final problems and I guess sort of the problems I put in a test. But, so, I mean, if you're practicing homework and it deviated really far from those kinds of problems, I wouldn't really worry about it. I think that's it. What?
He asked if Taylor was optional.
It's one of the options.
Yeah, Taylor-Maclaurin power series, that's in part 2, yes.
So
Yeah, the only series that are compulsory are these two. Convergence test and radius and interval convergence. The guys that go in line with Taylor series, they're in part 2.
So part 2, only one of the questions is on series.
Yeah, there's a question with several parts with the series.
So there aren't any bonus questions.
No bonus on the fun.
what would you
Which one think would be 92?
I mean, the only leniency the final has is that if you do everything in part 2, I'll grade the best ones. That's the only
Oh, really?
leniency you get.
Okay, that's good.
So if you want to try everything you can, then I'll grade the best ones. But other than that, there's no bonus.
Even, oh no, never mind, that doesn't make sense. I was gonna say parts of certain ones, but
No, you can't mix and match. You have to do complete problems. You can't do, oh, I want to do part A from here and part C from there. You have to do complete problems. Other general questions, concerns? Yeah.
For the approximation theorem, how do we judge it?
Oh, so basically, if you approximate something by n terms, the estimate is by the n plus first term. So that tells you how good it is. It's basically what it says. That's just saying if you have some series here, like minus 1 to the n, a, n, let's say that converges to s, then the difference between s and sn is less than or equal to the an plus first term. So, an example.
Can I give you an example?
Sure. Do you have one?
yeah.
This is spring 2006.
Spring 2006. Yeah, problem what?
Question 8. It's use a known series to approximate the integral from 0 to 0.1 of e to the negative t squared dt to 5 decimal places.
To 5 decimal places.
Yeah.
Yeah. So yeah, something like that is a kind of question that I might ask. It will be very similar to that. I probably won't say 5 decimal places. I'll probably tell you how many terms I want. But yeah, something like that is actually a good problem. What series would we use here? This Maclaurin for what?
For e to the x.
Right, so we know that e to the x is equal to what?
X to the n over n factorial.
Sum from 0 to infinity, right? So that's just 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus, right? So this would mean that my e to the minus t squared, I'm just going to plug in minus t squared for the x. So that would just be 0 to infinity minus 1 to the n, e to the 2n over n factorial. That gives me the alternating series, which means I can use the alternating series approximation. Yes.
Yeah, how do you know that was minus 1 to the n and not just...
Because I plugged in the negative.
Would it still be
I plugged in
valid?
minus t squared to the n.
Oh, you didn't
So the
do-
powers distribute.
Oh, I thought it was minus and then t squared.
Would it still be valid to plug in minus t squared to 2n? Would that, the way you wrote it right there?
No, I'm simply replacing the minus, this whole thing replaces x.
Right, but I'm saying instead of separating the minus 1 out of it, would it be valid to keep the minus 1? Could I write it
as this?
minus t to the 2 parentheses n over n factorial?
Yeah, that would also
Is that
be-
valid? Okay.
Yeah, if you wrote that, I wouldn't pick up.
All right.
But you have to do the integral also, right?
I wrote it like this to emphasize that it's alternating series. But if you realize that, that's what's going on, right? That's what tells you, because you can only use that approximation theorem for alternating series. So now that we can write this guy as a power series, we can actually try the integral, right? But the question is, how many terms should I use to approximate to 5 decimal places? And that's where the theorem comes in effect. So that means the integral from 0 to 0.1 of e to the minus t squared dt is just going to be the integral from 0 to 0.1 of the summation from 0 to infinity minus 1 and e to 2 factorial. And we can actually switch these because it's absolutely convergent. Then I just have a series now, and I'm going to integrate this. Minus 1 to the n is just a constant as far as t is concerned, so you just leave that alone. And then you add 1 to the power and divide by the new part. So this is t to the 2n plus 1 divided by 2n plus 1. And then you have this n factorial here, and then I'm going to plug in 0.1. So of course when I plug in 0, everything goes away, so all that's left is this series.
Now, if I kept it as minus t squared, parentheses, n to the,
you wouldn't have this, and you'd have minus 0.1 squared on the inside of the brackets. And then an n on the outside. So then n plus 1 on the outside. That's how it But yeah, so that's the series, right? That actually gives you the answer for this integral. But we only need to approximate up to 5 decimal places. So how do I make sure I get 5 decimal places? So by the alternating series approximation theorem. And such that an plus 1 is less than 5 decimal places, right? Which is 1 over this guy with 5 zeros. N is the number of terms I'm going to need. So it says I just need the n plus first guy to be less than whatever restriction I want. And so an plus 1 just means I'm going to take this guy and plug into n plus 1 and solve for n. This implies I want 0.1 to the 2n plus 3 over 2n plus 2. So I actually want n to solve that equation. And so now what n would work? You wouldn't have to go far. By trial and error, if you plugged in n equals 1 then what would you get on this side? You get 0.1 to the 5th over 4 times 2 factorial, which is less than 0.1 to the 5th, right? So we only need one term. So the approx is, plugging n equals 0 here, I would get 0.1 over 1 minus plugging n equals 1, I would get 0.1 cubed over 3. Alright, so here's where n equals 0. Here's where n equals 1. And according to this, I only need up to n equals 1 to get a good approximation. So basically the an plus first term tells you how good your approximation is, right? So whatever restriction you want, just make sure your an plus first term is less than that restriction.
Shouldn't it be n plus 2n plus 3 in the bottom left?
2n.
Denominator.
2n plus 2.
2n plus 1. I mean 2n plus 2, yeah, that's right.
2n plus 2. Yes, this is actually 2n plus 3. For the same reason here. I wrote it here, but I didn't write it down. Which means if n is 1, that's 5. Which it still works. Which means that this is, that's a 3. So this would be a 3 here. When n equals 0. And when n equals 1, that would be 5 times 2 factorial. That's it. Okay. So the idea is you have a bunch of series memorized. You should know the ones for e to the x, sine x, cosine x, 1 over 1 minus x. And basically, the function that they're telling you they're going to look similar, you just need to plug in what you need to plug in. Once you do that, you can actually integrate these series just as you would a polynomial, right? Add 1 to the power, divide by the new power. Once you do that, you get a series as the answer, and then you want to approximate it within some sort of specification. So all you have to do is make sure that the n plus first term obeys that specification, and then that tells you how many terms you need.
But if you tell us how many terms we need, we just need copying.
Yes, so the answer in that case would be we only need 2 terms. Right? We need the n equals 0 and the n equals 1. Other questions? Yes. Fall 9? But yeah, that was a good problem. You should know how to do that. And know how to do it if it's rephrased in terms of the number of terms as opposed to the number of decimal places and things like that. What did it say?
Use spherical coordinates, the vector z coordinate is simply mass, and the uniform density is solid hemisphere given by x squared plus y squared to the third is less than
Is less than?
a squared.
I want to find the z coordinate of center of mass. And they said specifically to use spherical, right?
And z is greater than
Z greater than 0. So basically we have just a sphere that's lying just above the xy plane. Right? It's uniform density, so the x bar and y bar would be 0, of course. You just have to figure out where the z bar is. You want to figure out that z coordinate. Right? So, how do we figure out the z coordinate? Z bar is equal to 1 over n times the triple integral over the solid of z times rho d, where your n is actually the rho here, and rho is probably a bad letter because they ask for spherical and we already have rho in spherical, so let's use a different letter. Capital D. D. What's the density here? It's a constant. Because it said uniform density. Right? Whenever they say uniform density, it just means the density is a constant. It's always the same throughout the object. Is K, the constant. Which means then, this means that your M is equal to, how do I set this up in spherical coordinates? Your dV, of course, becomes rho squared sine phi d rho d phi d theta. What's your rho?
0 pi over 2.
0. The rho?
Oh, no.
No.
0A?
Phi is 0 pi over 2.
And
And then 0 to 5.
Which actually, because this is a constant, this just gives you K times the volume of the sphere. So if you remember the form for a volume of the sphere, you can just plug it in. I never remember.
What does the E stand for?
E is just the generic name for the solid. In this case, E is representing the hemisphere. It's just a generic figure. So you would do that. Do we want to do that? So this is K rho Q over 3. Sine is minus cosine. So that's just going to be 2k pi a cubed over 3. What's the formula for the volume of the sphere?
A times x minus x initial plus
The volume of a sphere.
x minus h over x plus h. The center.
Huh? A 0, that's So the volume of a sphere is 4 pi r cubed over 3, right? And so for a hemisphere, it should be half that. So this actually follows, right? You could actually just, if you remember that, that was fine. But I never remember that. Right, this is actually k times the volume of the hemisphere. Right, so you could have actually done that shortcut.
That is that the integral?
No. Right, like this would give you 4/3 pi r cubed, and then you divide it by 2 because it's half a sphere, and then you get that answer. So yeah, you could have written this and then that. That would be fine for me, I would. So now we want to find the z bar. So the z bar is just going to be 1 over that, 3 over 2k pi a cubed times k. So the k's would cancel. Here I have 0 to 2 pi, 0 to pi over 2, 0 to a. And now I'm integrating z, which I know is rho cosine phi. What's the integral of cosine times sine?
Half the double angle formula.
Yeah, you can do that, but it's also, or just do substitution equals sine b is cosine.
Oh, right.
You could do it that way as well. So 2 pi's would cancel. And so now I have 3 over a cubed times a to the 4th over 4 times sine of pi over 2 is just 1. Sine of 0 is 0. So that's what I have. So I just get 3a over 8. So that's the z coordinate. So the center of mass, they never asked for this, but it'll actually be 0, 0, comma 3a over 8. And this is the guy they want.
Usually they would never ask us to find all the coordinates, right?
No, and I won't either. And typically, if they do ask you, it's something you'd be able to use symmetry on, because really, it's just doing a bunch of triple integrals. It's not. It's going to be mean to actually do like 4 of them. You know, if you can do 2 of them, they know. Yeah, you could do the other 2. So. Other questions? You said fall 2007?
Yeah.
Is that 6?
You want to see it?
Okay, this is a surface area problem. And it's similar to the problem I had on test 3, I think.
Yeah.
This is part of so you'll definitely have to know how to do a problem like that. So that's a surface area. If you'd like, you can sketch it. This is just an inverted paraboloid. But now we're cutting it off at z equals 1. We want the part that's above that.
So you only want the top part?
Yeah, only the top part. So that's S. I want to find the area. So what's the form for area?
It's a double integral of the square root partial of x squared plus partial of y squared plus 1. Yeah.
Integral over what?
I'm sorry, integral over e.
D.
D.
Here,
D.
where's D here?
The top part.
D is, remember, is a region of projection, right? Every time you integrate a double integral, there's a region of projection that you're integrating over. So in this case, the D would be here.
Right.
So first we have to figure out that D so we can set up that integral, and then we plug and chug this. Of course, this here is the F.
Right. So set the equation that you pulled 1 to find the intercept.
Correct. So for D, we set 1 is equal to 4 minus x squared minus y squared. So we just get x squared minus x squared plus y squared plus 3. So here you just have a circle here, 3.
Radius.
It's radius, it's square root.
of 3. And that's your D. Here, so your area would be the double integral over that D, and it's going to be the radical of, okay, the partial of f with respect to x, and square it, you get 4x squared, 4y squared, plus 1, right? Which, that's just 4x squared plus y squared, so it looks like a really nice integral to do polar coordinates with. So it's 0 to 2 pi, 0 to radical 3, because of here, and then this is the radical of 4r squared plus 1 r d.
And then
Is
you
it better to do direct substitution or u substitution?
U substitution, definitely, because of the r out here.
Because I tried to do direct substitution like for a problem like this also, and I just get stuck.
You wouldn't think of it. Yeah. Something like trick substitution is always a last resort. Once you have something to take off the du from the u, you use substitution. Right, so here you just use u is equal to 4r squared. So
Number 7 from the same example.
So that would just be 2 pi times, now you're going to have that 1/8 from here, times 2/3, 4r squared plus 1, 2/3.
and that's between 0 and root 3.
So that, so this and this goes into that, makes this 4, so we're going to have pi over 12. Plug in 3 here. Radical 3 here, so this is just 12 plus 1, that's 13 to the 3 over 2 minus 1. That's the area.
So if there were like restrictions, like in the first, then your data value changed, right?
Yeah, so in the test I said it has to be in the first octet, which means I actually cut off this, I cared about the part here. And so it only here, which would just affect, in this case your theta value would be pi over 2.
That was just a trick to make sure we were reading the question.
Yes.
I hate that.
Other questions?
7 from the same example. It's a series problem.
Now that's just a fancy way of asking for the interval of convergence, basically. Right? Instead of all x values where this converges, just asking for an interval. Right? Because you know for power series there are only 3 possibilities, right? It actually converges only at x equals -1, or everywhere, or on some interval. Right? So now we're just finding the interval. So what do we do here? Ratio test. Need L equals the limit of an plus 1 over an to be less than 1, where an will be defined to be that guy. An plus 1 is x plus 1 to the n plus 1 over n plus 1 squared times 2 to the n plus 1 times rearrange, so this cancels into the n. This is of course going to go to 1. This cancels that, so you just have a 2. And so you end up with x plus 1 over 2. And you set it less than 1 for convergence. So this means we need absolute value of x plus 1 over 2 to be less than 1, which means x plus 1 is less than 2. By the way, this guy here will be, they never asked for it here, but in the final I asked for it. This is going to be the radius of convergence. It's going to be half the length of the interval that we find. So now this just means minus 2 is less than x plus 1 less than 2, which means that your x is between 3 and minus 1. Right? So the length of the interval from minus 1 to 3 is length 4. half of that is 2, which is the radius of convergence. But remember, you always have to check the endpoints. It might be that it converges at the endpoints. So here you check endpoints.
Isn't it -3 to 1?
-3. Yes, I subtract. Yes. So when x equals -3, what happens in my series? The series will become
Negative.
which is actually that, right? Which converges by the alternating series test. In fact, that guy converges absolutely, but we don't really care about absolute convergence here. When x equals 1, I plug in 1 here. I get 2 to the n over n squared times 2 to the n. That's just equal to the sum of 1 over n squared, which is a convergent p-series. Therefore, the set of x values for convergence take everything in the closed interval will work.
Because of the negative sign, you can't.
Yeah, it's not a p-series if it's alternating. Yeah, which is no p-series. It's very, very specific. Only things that look like this are p-series, where p is a constant. I think this was from 1, 2. Which means that if you see something like this, it's not a p-series, right? It has to look specifically like this. It has to be a polynomial raised to a power, right? That's how you can compare it to a p-series. A single term polynomial raised to a power. That's a p-series. So this, because of this part, is not a p-series. It's an alternating series.
You say that
I know.
1 over ln x to the p is less than 1 over x to the p?
Yes, this is actually true. No, the denominator, x is bigger than ln x. For all x. For all x where the log is defined, of course, right? So the denominator gets bigger, what happens to the fraction? It gets smaller. So this is actually the other one. That would be true. So this doesn't have to converge. Even if that the other one converges.
I have a quick question. The k-term test, we can apply that to an alternating series, right? Like if we can see
Yes,
off
the k-term test can apply to anything. There's something else that stood out, but I can't remember that. But yeah, I saw people trying to apply p-series to a whole bunch of things that weren't p-series just because it doesn't work for arbitrary functions. What was it?
Don,
Yeah.
can you just go over like all the ways to know if something converges absolutely? If it's the comparison test and it's a absolute value converges, and that's that it, or are there any other?
That's it. So once you put absolute values around it, And if it converges, that you call absolute convergence. Right.
Doesn't the ratio and the root tests also give you...
The ratio and the root test give you absolute convergence right away.
So if you see that you can apply those, you don't have to screw around with that sort of thing.
Right. And again, if they give you a value of 1, it's inconclusive.
Right.
That you should know. If the limit comparison test gives you a value of 0, that's also inconclusive. I saw a bunch of people who had 0 and they concluded stuff from that. Right. It had to be a positive limit to get something from the limit comparison test.
And is there any way to remember that, like any reasoning for the limit comparison test?
Oh, it's isn't it for
I
like,
don't know.
if you change the numerator and the denominator, and you can't tell if it's if you made it smaller or bigger, then you have a comparison test. That's it.
Yeah, but you're talking about just remembering the formula. Sort of.
Yeah, well, that 0 is the value that you have to remember for the limit comparison test.
The idea is knowing that, remember you're comparing something to something else that you know happens, right? So if you're taking the limit of an over bn equals some constant, right?
Right.
Or, I mean, we called it L. So in other words, that's saying that an actually behaves like some, you can sort of think of it like an is just some constant times bn.
Oh.
Right? So it means they grow at the same rate. One is just a constant multiple of the other. Right? That's sort of how it works.
And
So now, if your L is 0,
then it doesn't give you any information.
it doesn't give you
but
any
if it's
information whatsoever.
Positive, then...
Positive, you know, they grow pretty much at the same rate. One's just a constant multiple of the other.
Cool. And what if they were what if it was negative, then?
Then they grow in the opposite way, which wouldn't really give you a lot of information. Because, you know, like, you go in the complete opposite direction. You don't know where this guy's going if he's not traveling along the same road.
Oh. Okay, so you just mark out, that's cool.
Yes?
But, does it 0 and limit comparison test give you, like, that the series converges? If OK converges, doesn't include?
No, it has to be strictly greater than 0. If you look on the table, it has to be strictly greater than 0. And
I have a different table, but I'm not sure like, if I'm interpreting it correctly. So it says that if it's 0, and BK converges, AK converges.
for which test?
Limit comparison.
Are you looking on the table that I gave you?
No, I'm using a different table that I used in the past.
It works if it's greater than 0. And just use the comparison test itself.
Oh, that's a very specific. That one says if in the case that BK converges, then AK converges. That means.
So with the limit comparison test, it doesn't work by itself, right? Because it just tells you if it works or not. And it tells you if you both converge on both sides.
Yeah.
So I guess you can test before you
Well, in theory, one of them you'll just know if it converges or not. One of them will be obvious.
Oh,
It'll be like a
BN,
P
the
series
BN.
or yeah.
You'll know who's the B.
Yeah. So AN is what you're given, and BN is something you develop from the AN, but you develop it in such a way that you know it will converge or not. So you usually don't have to do a test on B. Yeah.
Number 10, the same fall 2007.
Like fall 2007.
Well, we were working on it before, so
Maybe the rules.
yeah. So we got stuck on all of it. And realized we need mercy. Here. It's that one.
Okay, so it's another integral.
Yeah, but this time it's with tan inverse.
Well, it tells us to recall that. Hopefully we did. So now, And so A says find a power series for tan inverse. Find the min number of terms to compute tan inverse of 110 of course, justify your answer. Okay, so we can write tangent as an integral. The trick here is to write this guy as a power series and then integrate the power series. So here we know that tan x inverse x is equal to the integral from 0 to x of 1 over 1 plus t squared t. Now, here you recall that 1 over 1 minus x is equal to the sum of x to the n from 0 to infinity. Right? So the idea is you want to write this to look like that. So it's 1 over 1 minus t squared. And so now it's like this guy here, x. And so you just plug it into that power series form. So this is just going to be minus t squared to the n. Right? So
That's it?
so it does x to the n, so now it's just minus t squared to the n. Just replaces the x, right? And so this is actually dt. Now, absolute convergence says we can switch these, so this is just going to switch here, and you're going to integrate from 0 to x up.
Now, how do you know it converges absolutely at that point? I mean, it's...
We proved it. We proved it earlier. We proved
Okay,
that
so that's based on
once they're
that.
between minus 1 and 1, this guy converges absolutely to that.
Okay.
Same thing
all
for
right.
e to the x and sin x and cosine x.
Okay,
That's something you should know from before.
great.
So now you just integrate this term by term. So you're going to add 1 to the power, divide by the new power, plug in 0 and x. Plug in 0, everything dies, plug in x.
And negative 1 to the n is still constant.
Yeah, as far as t is concerned, yes.
Okay.
So this is just x to the 2n plus 1 over 2n plus 1. Right? And that actually gives you the power series for tangent inverse, right? So that's actually x minus x cubed over 3 plus x fifth over 5 minus x seventh over 7. So that's writing tan inverse as this is a Maclaurin series for tan inverse. By the way, if I plug in 1 here, what does this give me? If I plug in x equals 1, what would this series give me?
That's pi over 4, right?
Pi over 4, right? So it means that 1 minus a third plus a fifth minus a seventh plus a ninth equals pi over 4. You can actually write pi over 4 as a series by that. That was like the bonus from the last test. But yeah. Anyway, that's not what we're asked. Just curious one. Let's see. Right, so that's part A. That's the power series. Part B. We want to compute tan inverse of this. So now tan inverse of 1 over 10 is just going to be the sum from 0 to infinity of minus 1 to the n of 1 over 10 to the 2n plus 1 over 2n plus 1. Now I want to know how many terms do I need to make sure that that is actually within 5 decimal places of the answer. So what I'm going to do is I'm going to take this to be an.
But I thought the isn't the negative one to the n part not part of the an?
That's correct. We don't carry it. So I just need that the n plus first term to be less than the restriction that I'm given, and that I know from the alternating series approximation. So now I know that I want 0.1 to the 2n plus 1 over 2n plus 1 to be less than 0.1 to the fifth. So n equals 2 works. So we need 3 terms. Right? N 0, right? That's the n equals 0, n equals 1, n equals 2. We need those 3 terms. Other questions?
What can you use that, you said that dz over dx equals negative x0 over, when can you use that? When can you just jump straight?
That's implicit. When your variables are mixed together, you can't really solve for one explicitly. You can use that formula. So it's like just a random example. So I could just say something like something like that, right? Well, that one's actually not bad. Let's find dz dx. Because it's not that hard to actually solve. Oh no, so it's a cosine y, so y was fine. Right, so you see in this case, actually solving for y explicitly to get y equals blah, and then differentiating the blah is actually pretty difficult here. So that's where you use this, which is what we get from the chain rule. And that's going to be equal to minus fx over fy, where we have f x, y, z equals 0. Or any constant can work. So the idea is what you're going to do is you're going to get everyone to one side and then take that as the big F. Right? So here we have x cubed y z to the fourth minus 2x cosine y minus 7x squared minus 2x z equals 0. And this here is my F. So this means that dy d will be the negative of, then I just take the partial with respect to x of this guy, which is going to be 3x squared yz to the 4th minus 2 cosine y minus 14x minus 2z divided by, then I take the partial with respect to y of the whole thing. X cubed z to the 4th plus 2x sine y. Yeah, and that would be the answer. Here's another example using the same function. You can think of this as being the equation of some weird surface, right? So for the surface above on the equation tangent. Let's say 0, pi 0 or something. How would you do that? Huh? Right. So you start out the same way, get everything to one side, and you're going to find the gradient vector because that gives you a generalized formula for the normal. Right. So start here, find the gradient of it. In this case, I take the partial with respect to x, which I did there already. So this is 3x squared yz 4 minus 2 cosine y minus 14x minus 2z. Then you find the partial with respect to y, which I also found there, x cubed z to the 4th plus 2x sine y. Find the partial with respect to z.
4x cubed.
4x cubed yz cubed
Minus 2x.
minus 2x.
Yeah, this one.
And what that actually does is give you a general form for the normal. So this implies at 0 pi 0, the normal vector to your plane is just going to be the gradient f evaluated at 0 pi 0. So that would be 0. Cosine of pi is minus 1, so that would just give you 2. That's 0. 0, 0. That's also 0. This means the tangent plane is, now remember, just to remind you, this guy is A, B, C. This guy here is X naught, Y naught, Z naught, and tangent plane has the form A times X minus X naught plus B times Y minus Y naught plus C times Z minus equals 0. And so here it'll just be 2x equals 0. So literally the plane x equals 0. the YZ plane is actually the tangent plane. Usually you have like non-zero numbers, but I just made this up as easy numbers. But that's how you do it. Right? So if I give you some random surface, no matter how complicated it looks, and I ask you to find the equation of a tangent plane at a certain point, everything to one side, find the gradient, which is just the partials according to the components. So the partial with respect to x, partial with respect to y, partial with respect to z, and then you plug in the point, that actually gives you the normal, and then you use the normal and that to find the equation of the tangent plane. Do we have other questions?
You can ask us any questions with integrals and derivatives and power series. The issue I had was whether we switch, when we switch n equals 0 to n equals 1, or taking a derivative.
Oh, no, you won't really have to worry about that. Which, by the way, if you're doing that, you can always just leave the index alone. You don't have to change it, as it turns out. Like, so, for example, they only change it because it doesn't really make sense to keep it. So if you had this guy, and you have x to the n, and this was y, then if you're finding y prime, you could actually leave this as 0, and you get n x to the n minus 1, right?
Right.
But the thing is, when n is 0, you get 0 anyway, right? So this is just 0 plus blah, blah, blah. So what they did is they just forget about the n equals 0 term, forget it, and just start at 1. Right? So this is, you don't have to do that. They're actually giving you exactly the same series. But yeah, I wouldn't worry about it. You're not going to need it. 392 is already going to need stuff like that. 391, sorry, differential equations. That's where you're playing around with indexes, indices and stuff. If it didn't really show up in a test or like on past final, you don't really have to. Other questions?
Can you answer 4010 question number 12? Maclaurin series.
Oh, this was actually similar to the bonus problem. I think this is where I stole it from. On the fourth test. The trick here is to separate the numerator from the guys. So this write as t squared times 1 over 1 plus t cubed. And we know how to write things like these as series. This is 1 minus t cubed. So this does 3t squared times the sum from 0 to infinity with minus 1 to the n to the 3n, which is the sum from 0 to infinity of minus 1 to the n, 3t to the 3n plus 2. So that's a Maclaurin series for you. Yeah, Maclaurin is just a Taylor series at 0, evaluated at where the x naught is 0. Upon your center. Yeah, so a Maclaurin is just a special case of a Taylor series.
What about the n factorial denominator?
For what? Yeah.
But it's not.
Oh, it can cancel out. It means that the general form for your nth derivative had a factorial in it, which cancels out. That can happen. So here B is to note that ln of x cubed plus 1. You can just think of this as the integral of the integral from 0 to x of the sum
3t to the 3n plus 2.
Now you just take this, add 1 to the power, and divide by root. So that's expressing the log as a over C.
So if the series is not absolutely convergent, you can't take an integral of it?
No, you can't switch this.
Which means we wouldn't be able to integrate.
Right. And it's because of the rearrangement theorem that I mentioned before. Because remember, the integral of a sum is just the sum of the integrals, but then if you can move the things around and get a different answer, it means your limit, the integral is as a limit doesn't converge anymore. So it's actually illegal to do it. Other questions?
There's a rumor, if you get a 94 for the final, the passes with an
I don't know, who said that? Where did you hear this from?
Just a rumor.
I don't know. Maybe.
So that's the yes, maybe or no maybe?
Maybe.
Is there usually a curve in the final? Never?
The curve, the class grades of the row.
And A is above a 93,
Yes,
including 93?
including 93. Yes.
Really?
What?
With the drawing
Yeah, I believe that like a problem where I asked you to find like the volume or the area or something, I also asked you to sketch it.
It's saying like.
But it's nothing hard. It's like cones and spheres or paraboloids.
Oh,
It's nothing
yeah.
crazy.
No.
I'm not gonna actually draw that saddle thing.
Nothing like a hyperbola of one shooter.
Just like intersecting cones with spheres or something similar. Certain simple cylinders, things like that. Other questions?
For 2008. Sounds silly though. I just got confused.
Which one?
2C.
What?
2C.
Okay, so problem 2. You asked about part C, but we'll do the rest just as a refresher, I guess. Gradient of f is equal to what?
That would be
2xy.
2xy, and then 2yz.
X squared.
Okay.
Yes.
X squared.
2yz.
Squared plus 2yz.
And then y squared.
Okay, that's it. Alright, so remember this is just partial with respect to x, partial with respect to y, partial with respect to z. Okay. The tangent plane. So here we know that the normal vector is just going to be the gradient vector evaluated at the point 2, minus 1, 3. Which is going to be what? So you plug in x equals 2, y equals
4.
minus 1.
And then that's 4 plus minus 6, so minus 2.
4 minus 6, or minus 2.
And then that's 1.
Alright, so that'll be your normal. So this is your ABC, where your x naught, y naught, z naught is equal to 2 minus 1, 3. So the tangent plane
Is minus 4 times x minus 2. Minus 4.
Minus 4.
X minus 2.
Minus 2. Y plus 1.
Plus 1.
Plus z minus 3 equals 0. And part C. So we want b such that the directional derivative in the direction b of f is negative. But this means, how do you find this? It means you find the gradient of f at the point
2 minus 1, 3.
2 minus 1, 3. You dot product it with the v.
Unit.
And you
I thought it
want-
was the unit vector.
and you want to get something that's less than 0. So this means I need, this we already found. That's minus 4 minus 2, 1 dot product with v. I want that to be less than 0. So then, now all I do is just make v some generic vector.
1, 1 minus 1.
1, 1 minus 1. Well, no, well I meant like some ABC.
Oh.
So this means we want, and of course we're going to divide it by its magnitude later. So we want 4a minus 4a minus 2b minus plus c be less than 0. And you can pick anything for which this is true. So you pick any one you want. So I could pick 1, 1, 6. That could work. So I could let v equals that divided by its magnitude. That would work. Or I could say something like 0, 1, 2. That also works. There are tons of values there.
You can go straight to a unit vector, right? By just doing like 1, 0, 0.
Huh?
If you did like 1, 0, 0, you would go straight to a unit vector.
1, 0, 0 wouldn't work. That would give me, well, 1, 0, 0 would also work, yes. That would be negative. Oh, well, I was setting these guys equal to 0. I want actually less than 0. So I could make this, anything less than 6, anything less than 2 would work. So 1, 1, 1. Yeah, I would work. The vector j would also work. The vector minus k would work. So you pretty much plug in any ABC that makes this inequality true. Other questions? Fall 2009. What's the question?
Find the volume of the solid in the first box.
The number.
5.
5?
Find the volume of the solid in the first octave, which is bounded by the coordinate plane. Cylinder.
Okay, wait, first octant bounded by coordinate planes. Yeah?
Okay, and give cylinder x squared plus y squared equals 9.
X squared plus y squared equals?
9. And the plane x equals 6.
X equals?
X plus z equals 6.
And I want the volume, right?
Yes.
Okay, So now I know x plus z equals 6. Looks like what? This means that 6 slants this way. So what happens is the thing I'm looking at it's going to be a cylinder here, and then there's going to be planes cutting through it like that. So this, the part of the cylinder that's in the first octant, but it's being sliced here and sliced here. So I want to find the volume. So volume, several ways you can do it. You can do the triple integral of 1 dV, or you can do the double integral of top surface minus bottom surface, which is actually equivalent to that. In this case, personally, I let this be my D. And so this guy here is the top surface. This guy here is the bottom surface. So the bottom surface is Z equals 0, top surface is Z equals 6 minus X. Huh? The cylinder, this is x squared plus y squared equals 9 is the circular part. And then this is the plane, this one. Yeah. That's the slanting. So then I can have volume equals I can even switch the polar right away if I wanted to, which I think I'd probably do. So so I want R d Z d R d theta. If I want to do polar, what would the limits be here? What's theta?
Theta is 0 to pi over 2.
Yes, and R is?
R.
What's the Z? 0 up to?
6 minus.
Right, 6 minus R cosine theta. Another mistake I saw, people were switching to cylindrical and they had the X's and Y's still hanging around. You can't do that. Everywhere you see X replaces R cosine theta. Where you see Y, you see R sine theta. So that's the integral you're going to do, and that's going to give you the volume. So you integrate this with respect to Z, you just get Z, and you plug in that. So it's going to give you 6 minus R cosine theta times R. So you integrate that with respect to R, get 3R squared
6R.
minus R squared over 2 cosine theta.
How did you get R squared?
R cubed over 3. Because this is 6R minus R squared cosine.
No, because on the end, I thought when you said R cubed over 3, I thought it said R squared over 3. Sorry.
So now we have plug in the 3. And notice that I can't just jump the gun and put a pi over 2 here because there's a theta in the function, so that's going to be. So I plug in 3, I get 3 cubed, which is 27 minus 9 cosine theta. So this is 27 theta minus
9 theta.
This gives you 27 pi over 2 minus 9. Other questions?
Question about the drawing. Bounded by the octant, right?
It says in the first octant, right? That means this part where everyone's positive,
And
right?
it's also, yeah, so the y
It's bounded by the coordinate planes, right? Which means z equals 0,
Yeah.
x equals 0, which is over here, and y equals. I mean, yeah, this is actually a bad drawing. It should sort of look more like that, I guess. Yeah, because this wall cuts it off here, this wall cuts it off here, and the bottom cuts it off, and then there's a slanted plane going down here.
Wait, so now the angle is not 0 to 2 pi, right?
No, it's still 0 to pi over 2. It's still in the first octant.
It's just a drawing.
I mean, the drawing is a little bit.
He drew a semicircle, it should only be a quarter of a circle. Because the first octant, you see how the bottom is?
Yeah.
It's a quarter of a circle, so the
And
top
this
should be a
actually
quarter of a
hits at
circle as well.
6. And if this plane had continued, it would have hit x at 6 as well. Alright, that's pretty good. And this is a cylinder of radius 3, so that's 3 here. Other questions? Okay, I guess